Hello everybody, this is Gianluca with Modesto and this is the video number 5 on KiCad. Last time we defined this electronic circuit. Today I try to explain a little bit why the circuit is done in this way and what are the choices for the components of this circuit. Of course, what we have to do here is to understand the basic things. This is not intended to be a electronic lesson, but of course you guys will ask why we have exactly this configuration. Let me explain a little bit. So as you see, we have a connector, and for me here is where we get the power. So we will have 12 volts, and we will have whatever source that is not indicated here in the circuit to provide a certain amount of current. Okay, so we don't consider the current now that we will need in the circuit. What we focus on right now is on the different columns that you see with the LEDs. In these columns from the top you will have, when you close the switch, you will have 12 volts in this point, and on the bottom of course you will have 0 volt because you have the ground. Okay, so thinking about that, how we pick the different components, how we pick the correct LED, and why we have, for instance, 3 LEDs and not 2 or not 5 or something like that. So let's start to understand first which kind of LEDs we want to use. So in order to do that, I go to one of the different websites where you can buy components. My favorite is Mouser, and here you see I found the standard LED. It's an LED that costs 60 cents. Here it depends of course on the volumes, depending on the kind of LED, and so on. But here all information about the LED of course, but what I want to show you, this LED is a 2-pin LED first of all, with a package which is called PLCC2, and you see there are two parameters here which are really important. One is the forward current, 20 milliamps, and the other one is the forward voltage on the LED, which is 2 volt. Okay, these are the two parameters which are really important for me to define my circuit. Of course, the 2 volt forward current, forward voltage is the voltage that I have when the LED, which is actually a diode, so there is a junction, is working. So when the LED is active and there is current 20 milliamps through it. So what we have to consider, we have 2 volt and 20 milliamps for each LED. So that means from this point to this point we have 2 and 2, we have 6 volt. That means other 6 volt are from the 12 volt we have on the top of the resistor and the bottom of the resistor. So considering that we have 6 volt there, it's easy to calculate what is the value of the resistor if we want to have 20 milliamps, which is the maximum current we should consider, and we saw in the data sheet and we saw in the description of the LED, we should consider as current for the LED. So let's do the calculation so it's much easier to understand. So the resistor value that we have to choose is going to be basically the 6 volt that we have on that resistor divided by the 20 milliamps of current that we want to have going through the LEDs. Okay, and the result of course is 300 ohms, which is what I already wrote on the resistor that you can see here on the top right of the circuit. Okay, of course we can put the same value for all the resistors, so we will have this information to know and to remember what is our circuit. At this level, these values, they don't actually do anything. It's just to remember for us what is the value of the resistor, and then we will see also we will need something else. very soon, so 300 also here. And the other thing that is very important here, so we starting from the LED, right? So this calculation we did was based on the specific LEDs that we pick. Here we have the part number that we can copy. Okay, and then just to make sure it's clear what is what, we go to the parameters and we edit the parameters of the specific LED. And what we are going to do here, we create a new parameter that we call part number. And we passed the value that we just copied. So now we identify that that specific LED is as a specific part number. So when we get back and generate the BOM, the bill of material for this project, we will know exactly which kind of component we have to buy. Of course, we want to do the same thing from the resistor at this point. So we want to identify a resistor that has a 300 ohm, but we have to consider for the resistor what is the power is supported by the resistor itself. So the resistor, we have the value of the resistor. We know that we have 20 milliamps going through the resistor, so we can do the calculation of the power required by the resistor, or the maximum power if you want. So we go to the website and we pick a specific resistor with the part number. Okay, it can dissipate or 0.12 watts. So we find this resistor, we copy the part number of that resistor. We see that this resistor has a 0805 footprint, so we will see that, we will understand what it is, and you see that we have a 125 milliwatt maximum power. So this resistor is perfect what we need to do, and so we can go back to our schematic. You go on properties, and as we did for the LED, we add the part number also here, and we passed the value of the resistor. So at this point our components are defined, so the LEDs and the resistors, and of course we will see more. Now go to the next step in the next video. Thanks for watching and see you in the next video.